All right, today let's talk about loops and iteration. So the idea of loops and iteration, this just means like counting through things, working through lists. It turns out most programs are really very simple. They're a bunch of smaller hunks of code that we put in functions, and those functions tend to use repetition, loops and iteration, to do the same things over and over and over again, maybe with small modifications along the way. Because as it turns out, most of what we do is the same thing over and over again. Think about taking a walk. You may walk 1 mile or 1,000 miles. It's really exactly the same thing over and over again, right? Pick up a foot, put down a foot, pick up a foot, put down a foot, complain about the distance, pick up a foot, put down a foot, so forth and so on. And so it's really the same with programming. First, we're going to talk about definite loops. All right, so definite loops are loops that have a defined set. So maybe there's a specific number of values, or maybe there's a specific set that we're going to work with. And those are what we're going to talk about first. And this is the for loop. So for loops work with a defined set, and they're easy to recognize because of the word for. For is cool. So this is an example of a for loop, right? Definite loop, meaning we know exactly how many. We know exactly how many because there's this set over here. And this set actually is what we're looping through. We're saying for each one of these numbers, print the number out. Pretty easy, right? Same works over here. If we remember that was numbers, this set is strings, but the same thing still happens. I'm going to say for each one of those items in a string, print them out. Again, it's not really any more complicated than that. So let's take it apart just a little bit, look at the pieces, all right? So we have this for, which you know means it's a loop. It's going to go do something over and over again until some reason not to do it. In this case, the in is our magic word, our reserved keyword that does all the hard work. In looks at this set and says, all right, I'm going to know how many items are in the set so that you can loop through the set that number of times. So each number is simply a variable. I call it an iteration variable or an iterative here because what happens is this variable gets updated with the name from this, with the value from the set by in. So it says for, look inside this and see if there's a number. In says there's a 5. All right, so the 5 goes into each number. So each number now has the value 5, and then print 5. And it does this over and over again until it gets through it, right? So in then says, is there another one? Yeah, there's a 4, all right? So now this has the value 4, 4, 4. Print each number. And then, is there another one? Yes, for 3. Is there another one? Yes, for 2. Is there another one? Yes, for 1. Is there another one? No, there are no more. Skip that line and go on. It's that easy. With a little practice, these will come together really quickly. So I'm going to give you a bunch of slides that give you good hints, if you will. So that's my way of saying the slides ahead are good code that could help you a lot in things like homework. So here's a reminder of what we just talked about, simply looping through a set. And you can see this for loop is inside of my other programming. I've simply got a print statement that says print starting point. And then I loop through each thing, right? Is there something in here? Yes. Each now has the value of 9, print 9. Is there something in here? Yes. Each now has the value of 41, print 41, so forth and so on until we get to the end. Let's take a look at some others. Counting. Well, it stands to reason that since in is looking at each of those anyway, we can actually count them together. So in this case, I've got this start number, and yeah, that B shouldn't be there. I've got this start number, and what we want to do is say, give me my starting number, which was 0, all right? And then I'm going to count each one as part of my loop. So, 4, is there something in here? Yes, there is. There's a 9. So each now has the value of 9. So I'm going to say start number 0 plus 1 is 1. So, and then print out my start number and the number in my set. And then do it again. Is there another number in the set? Yeah, there's a 41 in my set. All right. Each now has the value of 41. Take the start number, which was 1. Add 1 to it. It's now 2. So now I've got 41 and 2, that should be in each. And so you can see there's a 2 and a 41, so forth and so on all the way through the loop. Let's take a peek at a few others here. All right, I need a sip of coffee, and you can take a look at this. What's going on this time? I'm just finding a sum. Right? In this case, I'm not using like a sum function. I'm actually just adding them together, right? So my counter is 0. My counter plus 9 is 9. And then, remember, we stay inside this loop, so it doesn't turn back to a 0, right? It has the value of 9. All right, so what's the next number? 41. So 41 plus 9 is 50. And that swoops around again. What's the number? Right? 50 plus 12 is 62, so forth and so on until we get to the end. So I can actually loop through a set to find out the value of the set by summing or subtracting, multiplying, whatever. Find an average. This is cool. So again, we still use that sum value, right? But in this case, we're going to find another one. Recall, what is the formula for finding the average, right? It's total value divided by the number of items. So you can see here, I use my addition, right? I find the sum of each of these as we loop through. And then at the end, I simply take that total value, 154, and divide it by my count, because I was counting up as well. As I counted up, I found there were 6 values in there. So 154 divided by 6. And gives me the answer of 25.666. All right? So let's do a little bit of filtering here. What do I mean by filter? I mean figuring out if something is in my list or not. That's really useful. I've got this giant list of a billion things. I want to know if one thing that I'm looking for is in there. Here's a way we can do it. I can take my 4 again. Remember, it's going to look at each of these. It's going to loop through. Values of 9. Is 9 greater than 20? No. Values of 41. Is 41 greater than 20? So forth and so on. And tell me whether it's larger or not. Right? So it actually will give me a list and tell me, well, how many of those numbers in the list were greater than 20. Looking for a Boolean variable. What I mean here is looking for true, false, 0, 1, yes, no, right? Boolean. So if found is false, then respond and change it to a true. So true and false are our values that can be used, just like zeros, ones, that sort of thing. And you see the same thing. It looks and says 9. Is 9 equal to 3? False. Is 41 equal to 3? False. 12 equal to 3? False. 3 equal to 3? True. So forth and so on. And I could count those if I wanted to, or just add the ones that are true, or just add the ones that are false, or so forth and so on. Continue to build on all of these ideas. All right, largest number. This is a little bit different. So we've given ourselves a value of -1, and then we're comparing that value. So if we come in here, we can simply change color here. We can see that our value starts with -1. And I say, all right, so -1 is the value I'm testing. So let's check this. Put a 9 in there. Is 9 greater than -1? Yeah. And we go so forth and so on, and things are groovy. The problem is that that -1 might cause problems, right? Because here's the smallest value so far, where you'll see it here in a minute. It causes this problem right here. We have a small value. We're testing everything against the smallest value. And we may not know what values are in our list. So it turns out checking against -1 is not always great. If we're concerned about it, we can use none. Another great keyword. None simply means there was nothing there. And so nothing is going to be, absolutely none of these numbers are going to be less than none. So it means that our first number is a 9. And as you can see, now we get a valid output from our list, not some arbitrary number that we picked. All right. One last thing to look at, range. So range works exactly like the values we were using. So when we use this in a list, and so we have a fixed list of numbers. Well, we may want to have just a generic, like for value in 30, just a generic number. Well, the way we would do that is by using range. So the way this works is for range in 5, print x. So what's it going to do? It's going to say, well, 0, 0, print 0. Now it's a 1, print 1. Now x is a 2, print 2. Now x is a 3, print 3, so forth and so on. Right? Because it's going to look in that range. And we can control this range. By default, range is always going to start with 0. Right? Why 0? Because good programmers always start with a 0. So if we want to start with some other number, turns out we can put a comma between them. Now this one starts at 4 and ends at 9. So you can see for a range in 4, print 4. For a range in 5, and it'll go up until it gets to 9. Now remember that, again, because we start at 0, we never count the last number. So this really should be read as 2 but not through, right? 2, 5 but not through 5. See, there's no 5 there. 2, 9 but not through 9. Right? If you remember that, you'll stay out of trouble. And then this one, same kind of thing. In this case, I'm saying what I want to count by. So I'm saying start at 0, count 2 but not through 10, and count by 2s. Right? So starting at 0, that's a 2, then it's a 4, then it's a 6, then it's an 8. Remember, 2 not through, so we don't see the 10. Make sense? I hope. All right, let's do a practice session here. Let's hop over and change to our, there we go, and pop up this in-class assignment. So this class assignment has us implementing a for loop for counting. All right, it's going to ask a user for a number and ask a user for a second number. So let's start there. Remember, we always have our name and our email. And our purpose. All right, so ask user for a first number. Oh, let's start. We're going to have our def main. All right, let's just start with, we'll call the first one first num. And I'm going to convert them to ints just to be safe at this point, and told me not to. Int input. Let me use single quotes. Enter first number. And do the same thing. I need to close my parenthesis there. And, you know, cuts and pastes are not a bad thing. We'll speed things up a little bit. Just remember we have to change the stuff. So second. Don't make that capital. Second number and input intent. Enter second number. All right, what's it asked for now? Now it wants us to implement a for loop for counting that counts up by 1 and displays it as it goes. All right, so we're going to implement a for loop. Counts by 1. Second number. Let's see, 4. And we need an iterative variable. Let's just call it each. That's the one I like because it makes sense. For each, we need our in. So we're not going to use a list, right? Because we don't know what our two numbers are going to be. It could be any first number and any second number. So we can't use something like 1, 2, 3, so forth and so on, because we don't know that this first number is going to be a 1. So we really need to use the range function. All right, so for each in range, and how are we going to know what our first number and second number are to put in our range? We could use the variables. So first num, comma second num. And by default, it's going to count by 1, so we don't really need to be explicit. Counts, second number displays each number as it counts. So no message, it just displays it. So put our, let's just put, what's it going to output as? Each, right? So let's say print each. And then displays a user-friendly message when done counting. Well, we don't want to put it inside our for loop, right? We don't want it here because then it's going to print every single line. So we want that out here. So print I'm done. Let's see if that runs here. get an invalid syntax error right here at the first one. What am I missing? I'm missing a colon. Let's try it again. All right, into the first number. Let's make my first number 42. What happened? Name var is not def. What on earth does that mean? Let's go up here and look. Let's see, I entered my first number. Took it as an input. And I got this weird thing here, var2 parenthesis. What does that mean? That means I must have missed something interesting, right? So open, closed, open, close. And then the second one, open, closed, open, closed. For each in range for a second each, I'm done. Maybe I'm missing it. Let's try it again. Oh yeah, I must just type something weird. All right, 42, make my last one 100. And look, it counts up all nice and neat all the way through the numbers, and it says I'm done. And I forgot my little I'm done. If for some reason, I'm sure I've talked about this before, but if I haven't, hopefully by now you guys recognize the escape character. What the escape character does is it says the next character normally would be something you'd read. As you can see, it closes my string, right? What it does is it says the next character should be treated literally, meaning don't do anything weird with it. Let's try again. Let's start at 0 and count to 15. Looks great. Perfect. All right, so there's our first end class assignment done.